Hello. Good evening, guys. My name is Yam Vekshit from section B. My roll number is 620206. Today I'm going to present you Newton's method using C language. Today we are going to discuss about what is Newton's method and what algorithm and flowchart we are going to use it, and what are the equations to solve this Newton's method. And we are going to take an example and we are going to manually solve a problem. And also we will discuss about the code, C code which we are going to use to solve minimum and maximum of the objective function using Newton's method. And we are going to observe the input by running the code, and we will also discuss the applications of Newton's method in our day-to-day lives. First of all, what is Newton's method? Newton's method is an iterative optimization technique that is used to find the minimum or maximum of a function. The basic idea of Newton's method is use an iterative process to approach the minimum or maximum of a function by finding its first and second derivatives, especially giving an initial guess of a minimum or maximum function. It uses these first and second derivatives of the objective function to calculate the new guess that is closer to the real optimum, minimum or maximum value. Algorithm. This is the equation we are going to use to solve the new guess of an Newton's method of objective function. Xk plus 1 is equals to xk minus f dash of x by f double dash of x. In this, xk plus 1 is the updated guess or the new guess we are going to find, and the xk is the initial guess which we are going to assume or it will be given in the question, and f dash of x by f double dash of x are the derivatives of the objective function. Newton's method is a powerful optimization technique that can converge very quickly, especially if the function is well behaved and it has a simple form. This is the flowchart of the Newton's method. Initially we are going to take an initial guess and we are going to find f dash of x by f dash of x and first and second derivative, and we are going to find the f dash of x and f double dash of x at the initial guess point, and we are going to calculate the new guess, and we have to do until the new updated guess or the initial guess or the distance between them is minimum. I will explain you by taking manually a problem. Here the function f of x is equals to x square minus 2x plus 1. We have to solve it using Newton's method. Initially they have calculated f dash of x and f double dash of x. Here we can see 2x minus 2 is the first derivative of the objective function. F double dash of x is equals to 2. Now let us take initial guess as x0, like we can take any guess. Here assume f x0 as 0, 0 as the initial guess point. Apply the Newton's method. We have to find the new guess using the initial guess, and after finding the new guess, if the initial guess and new guess are the distance between them is minimum or equal, then we have to stop the iteration process. If they are not equal, then we have to continue the process up to n number of iterations until the value becomes equal. Then we will be here, the initial guess will be the iteration process will be stopped at the second iteration, because the second guess value will be same as the first one. So the its minimum value is 0. Here this is the code we are going to use to find the maximum or minimum of an objective function using Newton's method. Here we have to write the objective function which we have given in the question, and we have to write the derivative of the objective function here, first derivative, and the second derivative can be written as here, and we have to write the initial guess which we assumed or it will be given in the question, and we have to set the maximum number of iterations, and we have to run the code. Here, after running this code, this is the example we have taken earlier. After running this code, we are going to get output as iterations 2 and the optimal solution. We are going to get the optimal solution at second iteration, and the objective function value is 0. It is the minimum value of the function, and it's an optimal minimum point. It is the entire code. Applications. Newton's method is widely used in optimization technique with many applications in daily life. Here it is used in engineering designing, data analysis, artificial intelligence, financial analysis, image processing, and it is used in designing of mechanical and electrical systems, and in many other ways it is helpful in our day-to-day life activities. Thank you. This is the code we have taken in the earlier explanation. Here the problem we have taken is x square minus 2x plus 1, and it's first derivative function, second derivative function, and the initial guess we have taken 0, 0, and the maximum number of iterations are 100. When we run this code, we will get number of iterations as 2 and its optimal solution, the value at which x square minus 2x plus 1 will be minimum is 1, and the objective function value is 0. Thank you.